Well, now we are moving on to our next topic, tension and acceleration. And the first question under this topic has been selected from paper 9709/41 for the session May June 25. And we are going to solve the first question from this paper, which is number 6. Let's read the question. Two particles P and Q of masses zero point 0.3 kg and zero point 0.6 kg respectively are attached to the ends of a light inextensible string. The string passes over a smooth pulley fixed at a point B where the inclined planes AB and BC meet. P lies on the smooth plane AB, which is inclined at an angle of theta degree to the horizontal when sin theta is equal to zero point 0.4. Q lies on the plane BC which is inclined at 30 degree to the horizontal. The string is taut and the particles can move on lines of greatest slope of the two planes. The particles are released from rest. It is given that the plane BC is smooth. Find the tension in the string and the acceleration of Q. So from the question we came to know that already plane AB is smooth given and BC is also smooth. So there is no normal reaction or frictional force at all, or simply weight is the force, weight and tension. So let us start our solution. Since there are two values to be obtained, one is tension, the other one is acceleration, there must be two simultaneous equation, and we we resolve the forces applying the concept of the motion law of Newton. So let us start with P. Okay, this is P. So this is the system of P. Then we are going to apply the concept of the motion law of Newton, and the direction is P is just moving up like this. Driving force minus resistance to motion is mass into acceleration. Well, so driving force for P is nothing when the particles were released, so P is moving up. That's why tension is the driving force for P. Tension and the resistance to motion is nothing but weight, because the surface is smooth in both cases. Both the surfaces are smooth. Mg sin theta. Mg sin theta is equal to mass of the particle P is zero point 0.3. So 0.3 A. 0.3 A. Then if we simplify, if you substitute the values, we will get tension is equal to mass of the particle is zero point 0.3 and acceleration due to gravity is 10, and sine theta is also given, which is zero point 0.4. 0.4 plus zero point 0.3 into acceleration. Hence our tension is going to be this 1.2 plus 0.3a. 1.2 plus zero point 0.3a. Okay, we may leave this as equation number 1, as we know that there will be two simultaneous equations because two values should be obtained simultaneously. This is for P. We could have written here over P. Then for Q, let us write for the particle Q. For Q is sliding down, so the direction is this, and we are going to apply the same concept of the motion law of Newton. Driving force minus resistance to motion is equal to mass into acceleration. Okay, and if we draw a system, then it will look like this. So for Q, nothing but the weight is causing Q move down. So we will write only weight is as driving force, or weight is mg sine 30 degree, minus resistance to motion is nothing but the tension, equal to mass of particle q is zero point 0.6 into acceleration. Well, then mass of particle q is zero point 0.6, acceleration due to gravity is 10 into sine 30 is zero point 0.5 or half, minus zero point 0.6 A is equal to tension. We may leave this writing one more step. T is equal to 6 and zero point 0.5, that is 3. So 3 minus 0 0.6 A, 3 minus 0 0.6 A. This is equation number 2. Now from equation 1 and 2, from equation 1 and 2, both of the right sides are tension, so they must be equal. If we if we do subtraction, then it is going to be, let me change the ink, it is going to be 1.2 or 3 minus, or 1.2, okay, 1.2 plus zero point 0.3a plus 0.3a is equal to 3 minus 0.6a. If we simplify, it is going to be 0.6 plus 0.3, that is 0.9. So 0.9a is equal to 3 minus 12, that is 1.8. Hence our acceleration is actually 2 meter per second, 2 meter per second square. Hence we can find our tension. Hence tension is equal to 1.2 plus 1.2 plus 0.3a, zero point 0.3 into 2 equal to, it is going to 0.6, 1.8, 1.8 Newton. So these two are the answers to the question. One is acceleration and the other one is tension. That's all about the first solution. Let's see the next question under the same topic. The next question has been selected from paper 9709/42 for the session May June 25, and we are going to solve question number 5 following the same concept. The question is a little bit larger, which says one end of a light inextensible string is attached to a particle A of mass 3 kg. The other end of the string is attached to a particle B of mass 4 kg. Particle A is in contact with the raft plane inclined at 30 degree to the horizontal, and particle B is in contact with a smooth horizontal plane. A second light inextensible string is attached to B. The other end of this second string is attached to a particle C of mass 5 kg which hangs vertically. Both strings are taut and pass over small smooth pulleys that are fixed at the ends of the horizontal plane. The part of the string from A to the pulley is parallel to the line of greatest slope of the inclined plane, and A, B, C are in the same vertical plane. The system is released from rest. In the subsequent motion, C moves vertically downwards with acceleration 2 meter per second, and neither A nor B reach a pulley. Find the tension in each of the strings. So there are two tensions. one string is behind B, another one is in front of B, connected to B. So let us start our solution. We can start our solution with particle C, and for finding tension we apply the concept of the motion law of Newton. So for C, start with C. If we write C, C is just hanging downward. We will write for C, for as it is moving downward. So our concept is driving force minus resistance to motion is equal to mass into acceleration. Well, driving force is nothing but weight. Weight is mg sine 90 degree, or you can call cos 0 degree sine 90 degree, minus resistance to motion is the tension in the string BC. Tension in BC. Here there is a little twist. Mass into acceleration. You may think that both the tension, both the strings are connected to C. So there should be tension in BC as well as tension in AB. There is a misconception in this case. Some students may get confused. Look, tension in AB, that means string AB is connected to BC. So all the forces, some of the forces, resultant force is acting on BC. So the tension in the string AB is also included in the tension BC. So it is just sufficient to write the tension BC, because all the forces, resistance forces is acting, including the tension force in string AB is also included in BC. So only it is about BC. That means AB plus BC in this case is equal to BC. So please don't get confused that why are we not writing tension in AB plus tension in BC. Actually, tension in the string BC is the sum of all forces. Well, then we can sum up, we can substitute the values. If we substitute the values, we will get mass of particle C is 5. So 5 into acceleration due to gravity is 10 into sine 90 is 1, which is unnecessary to be written, minus mass of particle C is 5. Acceleration is also given. Acceleration is given zero point 0.2, only 2, not 0.2. 2 is equal to tension in the string BC. Hence, tension in the string BC is going to be 50 minus 10 means 40 Newton. 40 Newton. 40 Newton. So that is one of the answers. Now we will find the tension acting or tension force in the string AB. Okay, this one. Well, so for AB, we will consider the particle P. So let us write for the particle B. For particle B, for particle B, B is actually, it is horizontally move onward. The concept is same always. For finding tension or an acceleration, we apply the concept of the motion law of Newton. So which is driving force minus resistance to motion is equal to mass into acceleration. Or driving force for particle P is tension in BC, because B is brought forward by the tension in the string BC. So tension in the string BC. Now resistance to motion is nothing but the tension in the string AB. At the same time, you may ask a question, why are we ignoring the weight? Actually, we are not ignoring weight. If we write weight is, or suppose weight is causing resistance to motion, in that case it is going to be mg sine 0 degree or cos 90 degree, cos 90 or sine 0, whatever you tell, sine 0 degree equal to mass into acceleration. Mass of particle p is, I mean b is 4 and acceleration is 2 meter per second. Hence, if we substitute the tension in particle, tension in the string BC is 40 minus tension in the string AB, and sine 0 is 0, so it is unnecessary to be written, which is 8 in the right side. Hence, our tension in the string AB is going to be nothing but 32 Newton. Okay, that is the final answer. So we have obtained both the tensions acting in each of the strings. So here just the twist is, don't consider that here BC plus AB should be written for the movement of C. All the tension forces, all the forces is now simultaneously acting on tension BC, I mean string BC. That's why tension BC is a sum of all forces, negative forces or resistance forces for C. So let's talk about the next question. Let's see question number B. B says, find the coefficient of friction between A and the inclined plane. So frictional coefficient, that is different topic. We will discuss it in other question. Let us solve number C. B, question number B belongs to frictional coefficient, which doesn't belong to our present topic. It will be discussed in the under the other topic. So let us solve number C. C says, when the system has been in motion for 1.5 seconds, the string attached to A breaks. Okay, find the total distance that A travels up the plane from the instant that the system is released from rest to the instant that A comes to instantaneous rest. Well, so let's start our solution. Since we skipped the solution to question number B, so some of the values should be extracted from B, which is frictional coefficient mu. Mu is equal to, frictional coefficient mu is 11 over 15, 11 over 15 square root over 3. No, I think this is not sufficient space. And normal reaction force R is equal to 15 square root over 3. These have been collected from solution number B. We can write here from B. From B, from B, solution to B, we have got this. Okay. Now we are going to find the displacement when the motion was when the particles were in motion for 1.5 seconds. So there are actually two phases. Some distance has been traveled before the string breaks, and some distance has been traveled after the string breaks. First of all, we will start with before before the string breaks. Okay, before the string breaks, we are going to apply the Shubert formula because time has been given. V is equal to U plus AT. That means we require the final velocity. Initial velocity was 0 because the particles were released from rest, and acceleration was given 2, time is also given 1.5. That means at the time when the string breaks, the velocity of the particle was 3 meter per second. Okay, So at this time, how much distance was traveled? We can apply the Schubert formula. So first part of the displacement is S equal to ut plus half a t squared. Okay. So our first phase is initial velocity was 0 and our displacement, I mean acceleration was half of acceleration was 2 meter per second, we know, and time was 1.5 second squared. Hence our first displacement before the string breaks is equal to 1.5 square means 2.25 meters. 2.25 meters. This is the first part. Now we will find the displacement traveled by particle after the string breaks. Remember, whenever the string breaks, it doesn't mean that all on a sudden the particle was at instantaneous rest. No, the particle was still moving up to some extent. So at that moment, there must be an acceleration or deceleration. Let us find the acceleration just when the string breaks. After that, what was the acceleration? And for finding acceleration, we will have to apply the concept of the motion law of Newton. So it is about to slide down in this way to a little extent. So driving force minus resistance to motion is equal to mass into acceleration. Well, so what was the driving force? As there is no tension acting, that means there is no force moving it upward, so driving force is 0. But resistance force must be applicable. What are the resistance force? Look, the plane was rough. That's why first resistance was the frictional force, which is mu r. And the second resistance to motion was just weight, which is mg sine 30 degree. Sine 30 degree equal to mass of the particle was 3 kg, so it's 3a. I mean 0.3. No, not 0.3, it's 3a. After that, we will substitute the values. Let me write just beside this. Or mass of particle A was 3. So it is, and mu, the value of mu is, already we have written here. This is the value of mu and this is the value of R, normal reaction force. So mu is negative 11 over 11 over 15 square root over 3. 15 square root over 3, and R is 11 over, I mean 15 square root over 3. R is 15 square root over 3 minus, that means force caused by weight. So mass of particle A was 3. Let us write 3 into acceleration due to gravity is 10, equal to acceleration is the mass of particle A is 3 and acceleration is to be obtained. So it is A. After simplification more, we will get 11 minus, both of them are negative, so it is going to be 30, 15, so 26, negative 26. So A is equal to negative 26 over 3. This is our acceleration of particle A when the string breaks up. Well, so using this acceleration, we can find the displacement after the string breaks. So we are going to apply the concept of Schubert formula. We know that V square is equal to V square equal to U square plus 2as. You know a formula, a relationship between velocity and displacement, and final velocity must be zero. Look at this, the particle A was moving like this. After at one stage it got stopped and came to instantaneous rest, then it started moving downward again. Okay, so we require when it was in the motion of 1.5, that means at this point. So at 1.5 second, suppose here it broke up, then this is the displacement made by particle A. Okay, so our final velocity is going to be 0 and initial velocity was 3. Actually we have already found here that initial velocity when the string breaks, it was 3 meter per second. So 3 square means 9, and acceleration is negative, which is 26 over 3, 26 over 3 and s. Now if we make s as subject, it is going to be negative 9 is equal to negative 52 over 3, 52 over 3 into s. Hence our s is going to be n 9 into 3 over 52, 52. Hence our displacement after the string breaks is going to be 27 over 52. So total distance, I think we can avoid this step. Let us write total distance. So for total distance, already we have seen that before the string breaks, the particle moved 2.25 meters, and after the string breaks, it traveled 27 over 52 meters. So total distance is going to be 2.25 plus 27 over 52 meters. So using our calculator, we find that total distance traveled by particle A is 2.77 meters. 2.77 meters. It is 2.77 meters. So that is the total distance traveled by particle A before and after the string breaks. So that's all about the solution to question number C. Let's find the next question under the same topic. The next question under the same topic has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 2, which says a van of mass 4500 kg is towing a trailer of mass 350 kg along a straight horizontal road. The van and the trailer are connected by a light rigid tow bar which is parallel to the road. There are resistance forces of X Newton on the van and 120 Newton on the trailer. The driving force produced by the van's engine is 2500 Newton. The tension in the tow bar is T Newton, and the acceleration of the van is 0.4 meter per second square. Find the value of X and the value of T. So there must be two simultaneous equations because we will have to find out two missing values. So first of all, start with the trailer. Okay, so for trailer, if we draw a diagram for both of the vehicles, it will look like this. So both the vehicles are moving on a horizontal road which is smooth. Okay, and the concept we are going to apply is driving force minus resistance to motion is equal to mass into acceleration. And as it is of the trailer, for trailer driving force is nothing but the tension is lying over here. This is tension is lying over here, Tn. So if we substitute the value driving force for the trailer is tension, because van is pulling the tension for pulling the van forward. So and resistance to motion is nothing but the weight. First of all, weight is what? Mg cos 90 degree, or you may tell sine 0 degree, minus on the trailer there is one more frictional force. Look at this, 120 is the frictional force on trailer. Mass of trailer is 350 kg, so 350 a. Okay, oh sorry, acceleration is also given, so we can substitute. Acceleration is given zero point 0.4, so we can write here 0.4. Then our tension is going to be, as cos 90 is 0, so weight doesn't have any force acting on this, so T is equal to 350 into 4, that is 120, plus it may be 140, sorry, 350 or 450. So if we multiply 350 by zero point 0.4, it is going to be 140. Hence tension in the string is going to be 260 Newton. That is the first part of the solution. Then for van, okay, for van, for van, both of them are actually moving on the same horizontal track. So for van, driving force minus resistance to motion is equal to mass into acceleration. Driving force is already given, so let us see how much is the driving force. Driving force is given as 2900 Newton. 2900, so let us substitute 2900 minus resistance to motion is the tension. And if you think that we are ignoring weight, we are not actually. So mg sine 0 degree, sine 0 degree, or cos 90 degree. In the previous case we have used cos 90 degree. Cos 90 degree equal to mass into acceleration. So mass of the van is 4500 and acceleration is given as zero point 0.4 meter per second square. Now let us substitute the values, and we skipped actually the frictional force on van, okay, which is x. So let it be substituted over here. It is minus x resistance to motion, I mean frictional force, and the tension is also causing resistance to motion. Then our value is going to be 2900 minus tension has already been obtained, which is 260 Newton. 260, and cos 90 is 0, so there is no force due to weight. After that, if we multiply 4500 by zero point 0.4, it is going to be 1800. which will be subtraction 1800, and tension, I mean x will go to the other side, frictional force. Hence our x is going to be from 2900. If we divide 2900 or 2500, I think it is 2500, not 2900. Driving force is actually 2500, not 2900. I made a mistake. It is 2500. So from 2500, if we subtract 2060, then it is going to be 440 Newton. 440 Newton is the frictional force on the van. 440 Newton. Look at this. This is 2500. So that is what the answer to the question, whole of this question. So that's all about this topic, and let's see our next topic.